Welcome to the Crazy Wisdom Podcast. My guest today is Chia. Chia is the co-founder of whyhow.ai, and they are a data infrastructure company, a knowledge graph studio for AI and RAG native knowledge graph creation and management. Very excited to dig into all of that. Welcome to the show.
Hi, great to be here. Thanks for having me.
So, a knowledge graph studio. Can you explain? My listeners have probably heard me talking and interviewing people about knowledge graphs because it's been something I kept on hearing. And whenever I hear something, I always want to dig in deeper. My understanding is that knowledge graphs were really important for search from when Google took over from the ontologies that Yahoo determined their search results based off of. Is that an accurate representation of the importance of knowledge graphs so far? And what are you guys doing?
Yeah, so that's definitely a good recap of the historical value for knowledge graphs and one of the main values for knowledge graphs. And fundamentally, knowledge graphs is a conceptually very simple idea, which basically says it's like a mind map, right? And it's a mind map of how you think different pieces of data are linked together. And so in the context of search, they are using these graphs to say, hey, these types of ideas and concepts are related to each other and they are related to each other hierarchically. So if I wanted to find something that's, adjacent to something that I'm searching for, I know to use this structured representation to search for something adjacent to it or recommend something that's adjacent to it, as opposed to like having some, AI um, system kind of navigate and suggest things in a less structured way, right? And so that structure helps you get a little bit more control, and you can do a lot of really cool like testing against it and kind of represent the world in a very specific way. There are also a bunch of other kind of traditional use cases for knowledge graphs, but the entire kind of high level idea is, hey, we have a bunch of different pieces of data out there. How is all of these data pieces like related to each other in a way that we can understand and comprehend and navigate?
Brilliant. So it's like a mind map, and we've got a bunch of abstract terms. What is the relationship to RAG?
Yeah, so knowledge graphs, has this long history, which we can talk about, especially in the context of kind of neurosymbolic systems. But one of the really interesting things and kind of why I think we're hearing more and more about it these days is because if we go a little bit back to the history, there were, generally speaking, two schools of thought about how we will reach AGI. And one school of thought said, we are going to throw a bunch of neural nets and deep learning and reinforcement learning, and we're going to throw a lot of these systems together, and we will build stochastic systems that mimic the way that brains work, and that will be how we reach AGI. And then there was another school of thought that said, well, that doesn't sound intuitive to me. I think we need to represent the way that the world works and a whole bunch of rules. And these rules and statements will describe the world, and that's how we will reach AGI, because that the world is really, really complex. And so historically, as we know now, machine learning won in kind of mainstream adoption terms, right? Transformer models, everything around that is fundamentally based on kind of more stochastic systems and processes. Now, when we started applying this to RAG systems, we noticed, I think, one very obvious limitation of it, which is that the way that the system believes and thinks about retrieving relevant context was by semantic similarity. And there was really very little you
Oh,
could do. Every single hack was really trying to like mash together semantic similarity to make sure that it works and is bringing in relevant information. And so at this point, you had this question where you had developers and domain experts look at the struggles of LLM and say, well, I can tell you what's relevant. It's right there in the text. Like, this is the piece that it's relevant. This is how it's related to this. So you just need to make sure that that connection exists, and then we can navigate that connection, right? And so that started bringing about this idea that, well, actually we can build neurosymbolic systems which combines the best of stochastic models with the best of rule-based systems and processes, because that will get us to kind of where we need to be. And so that's been the whole kind of interest around knowledge graphs and RAG and knowledge graphs, and kind of LLMs in general.
Beautiful. So I've been trying to understand this part about how we have an LLM. Because of that transformer architecture, it allows us to use GPUs instead of modifying pixels on the screen, but doing algebra, linear algebra with these arrays that essentially allow it to predict the next token. So the next, character in this stream of characters, and it allows us to simulate a response that sounds pretty good, like you're talking to an intelligent agent. Now, what I've been hearing recently is that while all that is beautiful, and I use this every day, I imagine you use this every day, there's a lot of people using LLMs to have a very valuable experience. Now, what I've been hearing is that the next step, which requires autonomous agents, requires reasoning. And OpenAI alluded to this, that reasoning is really important for getting to AGI, and it's also not solved yet. Is that accurate? And if so, what role do knowledge graphs play in that process?
Yeah, I think accurate in the sense that the industry agrees that there's a problem. I think any question you're going to have 10 different academic circles disagree, and so I don't want to wade into that reasoning debate necessarily. But I think what's evident is that there are at least flaws and gaps in our infrastructure when we're thinking about production grade systems, and a lot of what we're doing doesn't seem, super scalable. And so, yes, and I think part of why graphs came up is because it became obvious that you wanted to direct things and systems in particular ways, and in particular ways that had steps, because very trivially, that's how the world works. And so you started to see more and more graph-based methodologies pop up. So LangGraph, for example, and all these like graph-based agent infrastructure is a reflection of the fact that, well, yeah, we're not going to fine tune a model to perfectly reason through this tree steps. We want a way to be able to inject these tree steps in a very easy way and then kind of direct these powerful systems accordingly. And so the analogy I like in a piece that we published yesterday was, I personally like this analogy of SOPs and the fact that, doctors and lawyers and engineers have SOPs, and these are extremely smart people, but they still need to use these SOPs because it helps to direct them, and they're a very powerful system, right? So it's nothing about intelligence when I think about like structured reasoning and structured knowledge representation. It's really all about injecting a little bit more control and determinism and guardrails into a powerful system.
Brilliant. And for my listeners, there's such an interesting sort of almost philosophical learnings that we've had based on these LLMs, because these LLMs are probabilistic. So it's meaning that they're I'm going to butcher this, but they're the way that they determine that next token is through some sort of statistical means, and it hallucinates, so it could create something wildly different than what you're expecting. And if you ask it to do the same thing over and over again, it will hallucinate different answers to each different inquiry. And this is very different from what I understand to be the deterministic automation of the last 40 years, which is that you put in the thing, there's an input, there's the processing, and then there's the output, and it's deterministic what will happen. But it also means that it's somewhat rigid as well. And so these LLMs are less rigid due to this probabilistic nature. And what you're talking about is this knowledge graph somehow establishes some sort of deterministic ability to get it to production grade systems, which is what we all depend on, what civilization depends on. I really liked what you said about the SOPs, and it makes me think about listicles, like why listicles are so important for humans to capture the attention. Buddha gave us a listicle. The 10 Commandments are listicles. Like we have a bunch of listicles. We've got these language models that are just like have imprinted inside of my brain. Every time I put something into it, I get a listicle in response. But that's because it's been trained on all of humanity, which has an obsession with listicles. And now we've got doctors, engineers, lawyers also relying on listicles to do their job, SOPs. And so I think it's just absurd and funny and beautiful that it all worked out that way. production grade systems, if you have anything to respond to that, I would love to hear it. Otherwise, we can go into what a production grade system is, and go into the details on that. So let's do that. About 2 years ago, these things landed, and there's been a huge amount of hype. And I've tried to get it to do things that I want it to do, and there's problems with it. And then you've got large corporations also trying to get it to do what it wants to do. And there's a lot of hype, a lot of things that we're like, oh, these can be used for everything. But it turns out that they can't be used for everything. What have you learned about this process of trying to help people build production grade systems with LLMs?
Yeah. So I maybe one quick comment on the last
Sure.
piece, which is, I think that's a one favorite quote we have in the company by Andre Kapati is that, LLMs hallucinate, but that's the feature, not a bug. Like that's what we like the hallucinations until we don't like the hallucinations, right? And I think of production grade systems very similarly to the way I think about people, which is, going back to that reasoning debate. Like people will then say, hey, like the LM can't reason about X, Y, and Z, and then someone will inevitably bring up the point of, well, my cousin can't do that either. So, how can we say this doesn't reason? It certainly reasons better than, a lot of people I know. And I think that's a really interesting comment for a different reason. I think it's a really interesting comment because when we talk about like what you mentioned about production grade systems, the way I like to think about it is like this is a potential this is almost like a mad genius, right? That you can barely control. And like you could certainly see how a large organization might want the mad genius and use that mad genius for certain things, but you're certainly not going to promote it to be, director of ops anytime soon. And so what has happened over the past few years is it's all about being super constrained about what exactly this LLM
Yeah,
is
yeah,
going to touch,
yeah,
right? It's all about reducing the surface area of the LLM in your workflow, which makes sense, right? Because actually, that's how you would treat a mad genius in the real world, right? Like you are probably going to hide them somewhere, maybe in the R&D lab, and like make sure they don't touch too many things, as a human being, right? And so I think very similarly, that's what we're starting to see. But then you can also imagine that if you can get the mad genius to follow your SOPs and follow your, your worldview, then we're going to get somewhere, right? And so a lot of the emphasis, I think, is should be really about how do we represent structure and how do we represent rules and how do we incorporate these more symbolic rule structures, because that's the way that we're going to get them in. But you notice I use the word like rules and SOPs a lot, and these are not necessarily technical challenges, right? Yes, there's obviously kind of really interesting technical things involved when we think about how we get a model to follow these. But a lot of this is in my opinion,
yeah.
to a large degree, kind of taking in non-technical domain expertise
Yeah.
and representing them in a machine readable way.
Yeah, it's super interesting. We could get into some juicy territory here because it all comes back to the real world and solving real world problems. And we have a bit of a competency crisis, and we don't need to go into that specifically, but I think it's important to just recognize that there is a competency crisis. And a lot of this competency crisis seems to be around all these changes that are going on in the world. And all these changes in the world are divorcing from the real world problem because of various influences. The bigger one, in my opinion, would be zero interest rates, which create a sort of monetary pressure from this strange system where they're trying to control the economy through these various things. And so, in my opinion, there is a competency crisis, and that competency crisis, it feels like it's divorced from the real world and inside of these large organizations that have different economic incentives because they're dealing at a larger scale. So for a startup, it might be really important to actually fix a problem. But then inside a large enterprise, that problem is a puny little tiny problem. And the political or the other like pains inside of the organization that have very little to do with solving the problems, but have more to do with this large scale operations. So that seems related to this point of like, you solve this problem. There's an SOP for solving a problem. What is that based on? That's based on the actual intuitive knowledge that whatever operator is operating inside of this environment is solving, whether it be a lawyer, whether it be an engineer, they're solving this real problem. And then having the AI solve that problem in the same way they would solve the problem requires this solution, part of which is technical, but a lot of it's probably just that data gathering from that engineer or from that, but not only data gathering, because it's the data mixed with the intuitive way that they do their business. Is that accurate? What, if not, what do you think it really is?
Yeah, no, I think that comes pretty close. I think, you know, I can send you this article after this, which we released yesterday, so it
Yeah.
happens to be top of mind. But there's a book called The Checklist Manifesto, um, by a Harvard professor,
Okay.
and he basically talked about the effectiveness of checklists in healthcare
Oh,
scenarios. So
oh,
surgeons have a checklist, and initially surgeons were, if I recall the book correctly, initially surgeons were, insulted that they had to use a checklist because they are surgeons. And then it turned out scientifically it did improve processes. And I also think about scenarios like, in Japan, the bullet trains, if I understand it correctly, they'll do some very obvious things like look down the entire thing to make sure no one's there, even though 99.9% of the time it's very obvious if someone is there or not, right? Like kind of entering or exiting the train. Um, and so to me, like looking down and making sure that no one's entering and exiting the train is something so obvious. Like you and I would probably have missed putting that on the checklist, but it turns out, you can't really reason about these things from first principle. It's someone has screwed up. It's screwed up enough times that it's worth doing if you want to achieve perfection. And we have to put it on that checklist, right? Like there's no reasoning from first principles, as you said. There's no like magic intuition that will come up with this exhaustive list. It's just raw
yeah,
data from the
yeah.
way the world works,
Mm.
right? And so I agree with you, and that's I think what's really important, which is, you know, you can bring the smartest person into the room, but if they're not a mechanic, they're not going to reason from first principles how to fix a engine, right? Like it's the engineer who spent 50 years working on it who can tell you that some nut and bolt will unwind slightly every like
Yeah.
500 tries or whatever. Like that's just things that you're never going to figure out, right? And so being able to encode these things, I think, is really important.
Yeah, encode them. It's so interesting. Perfection. I really want to dial into that perfection checklist. It reminds me of when I was training to be a school bus driver, and they had us go through these checklists, and you needed to go through those checklists every single time. And they had like recording things to make sure you did because there were children on the bus. So it's like very important that you save the children. And so, but this point of we're training these machines to essentially do the job perfectly is really important for where the world is going, because very soon it seems, is sort of a question to you as well, is that it seems that we're entering a world where the machine will do things better than we can do them. And in driving, that seems great. Like it seems really important that this machine actually drives rather than I drive, because I can make mistakes that the machine probably over time with enough of that data encoding probably won't make. And that's important because that comes down to human lives and saving human lives. Then there's this, but then there's like, well, what do we do as human beings? Uh, and for me, when I ask that question, what do we do as human beings if the machine can do it better than me? Is, well, we have infinite problems left over. We'll have time. We're not seeing all the problems that we'll be able to solve once that happens. And there's some sort of problem solving human technique that probably still makes sense, but it will just sort of back into the meta strategy, sort of seeing the problems in the first place, being able to see a problem that a machine wouldn't create. Or there's the option to really just, a lot of people believe that it's just, we won't have anything to do because the machines will be able to see the problem, solve the problem, and but that's great because then all of our problems will be solved, right? What do you think on that matter?
Yeah, I think it's an interesting question. It's hard to. I think one of the interesting things is when you're like, there's a joke, I won't say which founder said it, but I wasn't smart enough to say it. But there's a founder of a data infra company that's the Series B data infra company, and he was on a panel with a bunch of other very famous founders, and they asked the panel the question, when do you think AGI is going to come about? And some people said 3 years, 5 years, 7 years. The data infra guy goes 20 years. Like we still can't figure out how to pass PDFs, right? So like let's talk about AGI when we can extract information from PDFs reliably. And the reason I tell that anecdote is a little bit like it's hard to kind of it's obviously always hard to imagine the inflection point.
Yeah.
B, it's definitely hard to imagine the inflection point when you're banging your head against PDFs, and then someone's telling you about this is going to be smarter than you, and you're obviously happy about that, but it's harder to imagine that. But C, I think also I have a lot of faith in the intelligence and malleability of humans in general, right? And while I don't want to dismiss the really real threat of kind of how the majority of society will be disenfranchised and disadvantaged by a whole bunch of different things that will come out, we're very smart as a species, and I'm sure we'll figure a lot of things out. And I think, as you said it best, like there will be even more questions that will pop up if someone can magically solve social inequality in the next 50 years. I'd love to see it.
That's great. That's
Yeah.
awesome. Uh, so, oh man, there's a great. Are you guys banging your head against PDFs? Like, what are the biggest challenges you guys are running against? Because it now I'll set this up a little bit more. I'm as soon as the LLMs came out, I was like, okay, this is it. This is the thing that I was missing 10 years ago when I was trying to learn how to code. Was that something there that could answer my questions and point me in the right direction once I got blocked. And it is great for that. And so now I'm learning how to code, I'm building applications, and it's like this thing that I was missing that's now here. And one thing I'm learning about is just how important data is. But then data is like this word that means something only within the context at which you say it. Like, so it needs to have like data for what? And so it's like this very meta term, but it's also a very practical term once you're trying to do things. And so where are we now in terms of data? In order to answer the question that I have, I need to give the LLM all this data, and I can't give it all of the data that matters. And it feels like that's not necessarily a technical problem. That feels like a problem in my own understanding of how to get the data from from this giant program that it has created for me, and then get that data, the right data that it needs. What have you learned from data and knowledge graphs, and like just in general, but also specific to knowledge graphs?
Yeah, so I think that's a great question because it reflects a little bit about how we think about things, which I think is a little bit different, which is um, we have a lot of faith in LLMs and how LLMs will get smarter and more powerful and things like that. But you're right, because if we go back to like that mad genius example, a mad genius in surgery is not going to be a mad genius in engineering.
Yeah, yeah, yeah.
Um, and so a lot of, the problems with different contexts is a non-technical problem around like how do I represent knowledge
Yeah.
in a really in a useful way, right? Like this is a matter of the limitations of language. This is a matter of the limitations of semantics, right? And then how do you encode that, given the limitations of language, how do you encode that in a way that can still can fulfill our needs, right? How can we communicate? Because you and I can be very smart people, but we'll probably disagree on 10 different things. It's not because like you're dumber or I'm dumber. It's because, again, the way that we
Yeah,
think about
yeah,
knowledge in our head is very different, right? So we're starting to run into very interesting limitations in that way. But that's why I believe like solving these issues is less of a technical problem, although
yeah.
that's certainly going to be a part of it, but it's a multidisciplinary issue, which gets complex really, really quickly, right? Um, but I want to caveat all of that by also saying like you can reduce it theoretically to this really tough, abstract, multidisciplinary problem. Um, and I think building a really good business is about balancing that with the idea that, hey, models get better.
Yeah,
just
yeah,
chuck it into the
yeah,
context window. And you know what? 10% of the time, yeah, it completely works and you don't need to be super smart about it, right? Like, so like taking that very balancing the kind of end state and frontier of the complexity with like the
yeah.
practicalities of like actually LMs are pretty powerful, right? Like you don't think too much. Like I think of that like IQ curve all the time. And so it's always like important, I think, if you're trying to build practical systems to like figure out what lands where, you know.
Brilliant. And so is what you guys are doing, so knowledge graphs, from my understanding, have to be encoded by a human in that process that we're talking about, at least before. Is that accurate now? Have LLMs changed the way you actually create a knowledge graph? Like, I believe that knowledge graphs were handcrafted, like in the time of Google or maybe even Yahoo, like an expert had to go and craft the knowledge graph based on their implicit understanding. Is that still the same case? And is that what you guys are doing?
So that used to be true,
Uh,
I think, and obviously it's still very new, but we are very much focused on how do you use LLMs, how do you bring together LLMs, developers, and non-technical domain experts
Got
in
it.
a single workflow to accelerate all of that,
Oh,
right?
cool.
And so you're absolutely right. Like these systems, you know, used to take millions of dollars, huge teams. And the reason it was never super popular was because you can imagine the only people who could justify doing that, like Fortune 500 companies or Fortune 50 companies
Yeah.
doing these systems. Whereas now, I think like the potential of models to assist the process, the excitement, I think, of, you know, domain experts to engage with these systems and also obviously developers, like means that like the opportunity to capture expertise has never been possible until now.
That's super interesting. And that's what you guys are building, is the pipeline for these people to work together. Can you talk more about some of the people that you're helping, not naming any names or leaving anything, any confidential stuff or anything, but can you talk
Yeah.
more about examples of getting these non-technical experts their input?
Yeah. So the first caveat is like almost all our design partners are technical, but they are working with non-technical domain experts. And so we're currently working with like,
Oh,
you know, Fortune 500 companies, all the way to startups across like financial, healthcare, manufacturing domains, and they want their information represented in a structured way because then they can, you know, query against it in a structured way. So that begs the question of like, well, you know, I can represent it in a certain way. And if I was a developer, I could probably get, you know, 60, 70% of the representation. Like, you know, they've worked in X big company for 20 years. They do understand the domain.
yeah,
They're not
got
like
it.
stupid
Yeah,
about the domain. But, you know, there will be certain small things, right? Like you want to double check. The business owner needs to take a look at and verify that these are things they care about, or this is the best way to represent it, or there's any context they missed out. Like that kind of interaction, we help to facilitate. And I think what's also interesting in what we've built is that we also have a segment of users who are like slightly technical domain experts. So think like your accountant or doctor, or like manufacturing operator who like knows Python, and these are all like real people. And they've come to us and said, "Hey, look, I know enough Python to be deadly, and honestly, LLMs make it a lot easier.
yeah,
Um, I know that the thing I can bring to the market is like my domain expertise that no one else knows,
yeah, yeah,
right? And so I want to represent that because if I can represent that in a way, then in, you know, a structured way, then anyone who's querying against that structured graph, like it's almost like talking to me, the expert, right? But in a context-aware way.
yeah. Brilliant. So it's like automation. It's going back to that deterministic versus probabilistic thing, which is that most people would love to automate their jobs because then if they're curious, they can go learn more things and be more effective and do things like that. And now we've got this technology that can in a hallucinatory way, automate parts of our jobs and parts of our know-how, which is so interesting. So many philosophical questions in that, embedded in that. And so it's really beautiful of giving them a way to do it. So if somebody does know Python, can we go into the technical aspects of what you guys are doing there? You run on Python. Can you talk more about like the platform that you built?
Yeah, for sure. So our platform consists of a Python SDK as well as a UI UX. And so the UI UX comprises a lot of the workflows that we think are necessary to bring in the non-technical domain expert, or at least make it easier for this person. We think a lot about, so our platform has kind of three things that we think are important. So number one, which is multiplayer graph creation. Number two, very granular control over the schemas that you're using to create the graphs. And then number three, being able to think about modular graph creation, especially as you think about multi-agent workflows, like each agent
Oh,
representing a single domain,
oh,
representing a single graph, right? And so this is makes it a lot easier to do any kind of multi-agent orchestration things. And then and so that's kind of where we're at on the platform. And then maybe one last point I'll raise is on kind of the historical difficulty about graph creation. The historical before LLMs were used to really kind of look at the graph and understand the graph, you had this you had systems which attempted to represent everything, right?
mm,
And so when I mean everything, I mean like they would say, hey, you need to know that a house is a building, right? Or and then you needed to
I got
know
it.
that, yeah. And so because you have to represent so many things, you can imagine like the amount of effort to then build like a system that made sense was really hard. Whereas now, even if LLMs hallucinate, I think it probably won't hallucinate that a house is not a building,
Yes,
right? I
yes,
think
yeah,
you and
yeah,
I
yeah,
can be at least
yeah,
confident of
yeah,
that one point.
yeah, yeah.
And so then the barrier for the amount of representation you have to do has just gone down, right? And as models become more and more powerful, like the more and more like
Yeah,
basic
yeah.
fundamentals, you don't have to represent, right? And so you can focus on representing only the complex things that you care about.
And that brings to mind edge cases. From what you just said, makes me think that there are a lot of edge cases. That's where you guys will become really valuable, is identifying some of those edge cases. But the LLM is basically taking out anything that's not ambiguous, not too complex. Like the LLM is going to be able to do a lot of that grunt work that used to be done by a highly trained human, very expensive human. Really interesting. Are you drawn to? I know that you guys are heads down in the startup life, which is very demanding, and so sometimes it's hard to back out. But what we've been talking about are these deeply philosophical territory about the nature of reality and the nature of language mediated reality, which used to just be something philosophers were discussing. But then through training these machines, we've learned about the way the reality actually works. And I'm curious if you are into this, or have you learned anything philosophically speaking about the nature of reality based on training these things? Is it something that is attractive to you?
Yeah, I mean, well, in high school, I did I wrote a paper about the interplay between language and reasoning, right? And so this is why I keep going back to linguistics, because and linguistics is also what I studied professionally for a bit, to an extent. But for me, I think the biggest roadblock, and what's most interesting about this entire process, is the biggest roadblock to AI development is going to be just the limitation of language, right? And the limitation of language is fundamentally what we're using to communicate, and we're running into like the actual limitations there, because day to day, you and I, again, both of us might have disagreements, but we'd probably still say we had a conversation, we understood each other,
Yeah, yeah,
even though that, like,
yeah,
if you think about that at the extreme, that's not true, right? Like, you
yeah,
don't actually know what I meant
yeah,
in the way that I meant it, right? And
yeah.
similar, vice versa. And this becomes a problem if you're then trying to build very complex representations. So to me, that's the interesting bit. Like, I'd be really fascinated in kind of thinking through, well, because this fundamentally, that there is a philosophical question, right? Like, at the extent at the frontier, like, um, given limitations of language, can we really build like
Yeah, yeah,
truly
yeah,
complex
yeah,
systems,
yeah.
right? And then I know there's a bunch of people who are now talking about, hey, like, actually English might not be the best way for systems to be built on,
What are
right?
they?
Like,
What language
maybe
are they saying? What language are?
there's like,
Yeah,
this goes back to the long history of like
yeah,
bots coming up with their own language to
yeah,
communicate because it's more efficient and stuff like that. Well,
yeah.
like, who Is it like no one? No, I don't think anyone really has a good answer here. At least the ones that I've read and understood. But I think that's the really interesting question because that's what I deal with kind of day to day, which is yes, like we're building all these agentic systems, but sometimes you get hints about like why language as we are using it today is just suboptimal to get perfect representation, right? Like no language can claim that they can perfectly represent, like it's just also conceptually kind of very difficult to think about. So that's a piece about what
Yeah,
we're
thank you.
working on that fascinates me.
Thank you for sharing that. And that seems to go into something I've become trying to figure out myself is, so why is Elon Musk building Neuralink? The reason he says it is building Neuralink to do a direct brain interface is so that we can speed up communication because language itself is a limiting factor with communication. As you mentioned, you correctly identified that what I mean when I'm using these words is probably it's based off of my entire history. And there's so many things in my entire history that you couldn't be aware of, and same and vice versa. And so Elon Musk is trying to build Neuralink so that we can do direct brain interface to speed up communication so that we can compete on the same level playing field as an AI who may or may not have consciousness and the ability to think about its own goals and wanting to have its own goals and that may not align with our goals. And what you just gave me is a very interesting thing because it's not only the speed at which the language is spoken that the brain interface gets a jump with, but it's also the fact that if the AI created its own language, if there's an AI directly interfacing with my own brain, then I would be able to speak that language as well. And so that there's a sort of a jump in getting around the limitations of language. Do you think about this in terms of do you think about Neuralink in this way and these direct brain interfaces in this world? Like,
It's not a practical day-to-day question for us. It's definitely interesting for sure. I mean, it doesn't affect us practically. I'm interested to see how language changes and
ooh,
communication changes. Um, but yeah, I wouldn't say it's I wouldn't say it comes up in our stand-ups.
yeah. What are the big milestones you guys are looking to hit?
Yeah, so we are still in the middle of a beta. We're launching our SDK this week, so we're pretty excited about that. And so we're still kind of very slowly unwrapping the first few kind of layers of our product. So I'm really excited about the next few kind of days and weeks. And I think that's really kind of what we're excited about. And then we're pretty excited about some of the partners and systems and kind of features that we are building. I think one of the things that excite me a lot is really kind of unifying all these different types of people together in a single workflow to make these systems a lot smarter and better and deterministic and adopted. And so I'm like pretty excited about kind of a lot of the work we're doing over the next few months.
So basically, there's this beta program that you've been running. You've been enrolling non-technical experts and some technical experts into this workflow, and then that's the real product is and the next step is to essentially refine that so it's really reflecting how these people are working.
Yeah, it's mostly developers, and then also their associated domain experts. But
Mm-hmm.
yes,
Mm-hmm.
and so the primary person we talk to, sell into, speak to, kind of data scientists, VP engineers, CTOs, that kind of thing. But yeah,
Great. And then, are you guys looking to hire anybody?
not at the moment, but we're always down the chat with super sharp folks.
Nice. So a few minutes more left. Is there anything that I didn't ask you that I should have asked you about knowledge graphs and how they may be important in the future?
Um, I suspect we'll see like a resurgence of like neurosymbolic startups talking about neurosymbolic systems a lot. So I'd be excited to track kind of more and more companies adopting neurosymbolic approaches to solving real life problems. I think that's something interesting. I think the other thing, if folks are interested in knowledge graphs, feel free to find some time on my calendar, check out our website, check out our Medium articles. We're always down with a Discord group where we geek out about stuff like this. And I think, yeah, the last thing I'll say about knowledge graphs, which I love, is that knowledge graphs are one of those things which are like conceptually accessible. So like a lot of people can participate, because again, I think that at the limit, you need like a really strong multidisciplinary understanding of the world, of language, of knowledge, of real life work use cases, and how LLMs work, for you to like really get into it. And like that's why I enjoy this space a lot, because it's a lot more accessible to everyone.
Cool. Thank you so much.
Yeah.